Welcome to today's paper reading. Today's paper is titled, Verifiable by Design, Aligning Language Models to Quote from Pre-Training Data. This paper was published on the AR14 preprint by Jingyu Zhang and colleagues from Johns Hopkins University. The abstract highlights the challenge of verifying the correctness of large language models, LLMs, against trusted external sources. Recent efforts to enhance verifiability, such as providing citations, still lack guarantees on correctness. To address this, the authors propose quote tuning, a method that aligns LLMs to quote verbatim statements from trusted sources during pre-training. This approach uses a fast membership inference function to verify text against a trusted corpus and designs a reward function to quantify quotes and model responses. Experimental results show a significant increase in verbatim quotes from high-quality documents, ranging from 55% to 130%, while maintaining response quality. Quote tuning also demonstrates the ability to generalize quoting to out-of-domain data and provides additional benefits to truthfulness. This method not only simplifies the quoting process, but also opens new avenues for improving LLM trustworthiness through better verifiability. Large language models, LLMs, have shown the ability to generate fluent text and follow instructions, as evidenced by recent advancements. However, these models are also known to produce outputs that appear plausible but are actually erroneous, a phenomenon often referred to as hallucinations. This poses significant risk to users as it becomes challenging to fact-check these seemingly convincing generations. One of the key requirements for LLMs is verifiability, which involves grounding their responses in supporting evidence and making the produced claims easy to verify for humans. This capability is crucial for building trustworthy human-machine relationships. Figure 1 illustrates the three-stage pipeline of quote tuning, which involves generating multiple responses from a pre-trained language model, constructing preference data by ranking these responses based on how much they quote from a desired corpus, and then optimizing preferences to align the model to generate more quoted statements. This process aims to enhance the verifiability and trustworthiness of the model's outputs by ensuring they are grounded in high-quality, pre-training data. In this work, the definition of a text string X being quoted from a corpus C is established if a verbatim copy of X is found within C. This approach enables the use of data portrait, a membership testing tool based on Bloom filters, to efficiently check if text n-grams have appeared in the corpus. Specifically, the Quoted Information Precision Score (QIP score) metric is used, which measures the percentage of n-grams in X that have appeared in C. The QIP score is calculated using an indicator function implemented by data portraits, which returns 1 if the n-gram is in C, otherwise 0. Note that exact match quoting is considered a lower bound due to potential white space mismatches. The original implementation uses character 25 grams unless otherwise specified. Quote tuning involves several key steps. First, multiple responses are sampled from the pre-trained model for each prompt. Next, preference pairs are constructed by selecting responses that meet specific quoting and length constraints. The preferred response must have a higher quoting score than the dispreferred one, and their lengths should be similar. If multiple pairs meet these criteria, the one with the highest average QIP score is chosen. Finally, the synthetic preference dataset is used to optimize the model policy. The benefits of this approach include improved verifiability, reduced hallucinations, and enhanced truthfulness in the generated text. In this section, the authors present empirical evidence on how quote tuning can enhance the verifiability of LLM-generated responses while preserving generation quality. They conduct experiments on two main tasks: long-form QA and open-ended text completion. For the long-form QA task, they use datasets like Natural Questions and ELI5, and compare their method against baselines including best-of-end QIP re-ranking. The metrics used to evaluate these tasks include QIP score, BART score, Rouge-L, and perplexity. The results show that quote tuning significantly improves quoting accuracy, even outperforming more computationally expensive baselines. Additionally, it maintains or slightly improves answer adequacy and fluency. The authors also test the out-of-domain generalization ability of quote tuning, demonstrating its effectiveness on the ELI5 dataset. Table 1 showcases the impact of quote tuning on Llama 2-7B chat outputs. Before tuning, the model's response had a low QUIP score of 3.9, indicating minimal quoting from Wikipedia. After applying quote tuning, the QUIP score dramatically increased to 60.6, demonstrating a significant improvement in quoting accuracy. This enhancement not only boosts the verifiability of the generated text but also maintains the quality in terms of adequacy and fluency. The highlighted segments in the table illustrate the quoted text from Wikipedia, which quote tuning effectively incorporates into the model's responses. The analysis reveals that quoting from high-quality corpora like Wikipedia enhances model truthfulness. This is evidenced by the quote-tune model's performance on the Truthful QA dataset, where it shows increased truthfulness and informative answers compared to the untuned model. However, there is a slight drop in informativeness, indicating a more conservative approach. In terms of downstream performance, quote tuning results in minimal degradation on general capability benchmarks such as MLU, GSM-8K, BBH, and HS, while significantly improving quoting. Additionally, an ablation study on the length constraint of the quote tuning algorithm shows that without this constraint, responses become notably shorter, quoting is reduced, and perplexity worsens, highlighting the importance of the length constraint. Table 2 presents the results of applying quote tuning to long-form question answering (QA) datasets. The table shows that quote tuning significantly enhances the QUIP score, a measure of quoting accuracy, across both in-domain and out-of-domain QA tasks. Despite this improvement in quoting, the quality of the generated answers, as measured by Rugel and BRT score, remains consistent with baseline models. Additionally, the perplexity of the generated text, a measure of fluency, is also maintained or improved. This indicates that quote tuning not only increases the verifiability of the responses but also ensures that the overall quality and fluency of the text are preserved, making it a valuable technique for improving the reliability and truthfulness of large language models in QA tasks. Table 3 illustrates the effectiveness of quote tuning in an open-ended text completion setting. The key findings show that quote tuning significantly enhances the QUIP score, a measure of quoting accuracy, by a substantial 130.4% relative to the baseline Llama 2-7B model. Despite this improvement, the adequacy of the generated text, as measured by metrics like Rugel and BRT score, remains comparable to the baseline. Additionally, quote tuning notably reduces perplexity, indicating better fluency in the text generated. These results collectively demonstrate the benefits of quote tuning in improving both the verifiability and readability of text generated by large language models. Table 4 presents the results of the Truthful QA evaluation, showing that quote tuning enhances model truthfulness without being explicitly tuned for it. The table highlights that truthfulness improves by 14%, while informative answers slightly decrease by 2.7%. Additionally, the combination of truthful and informative answers increases by 10.5%. This suggests that quoting from pre-trained data indirectly boosts the truthfulness of generated responses. Table 5 presents the evaluation results of quote tuning on general capability benchmarks including MLU, GSM-8K, BBH, and HS. The data shows that while quote tuning leads to very small degradations in performance, less than 2 points across all benchmarks, it significantly enhances the quoting capabilities of the model. Figure 2 illustrates the length distribution of dispreferred and preferred responses in the NQ dataset, both with and without a length constraint. On the left, without a length constraint, the density of preferred responses is notably higher around length 100 compared to dispreferred ones. On the right, with the addition of a length constraint, length equals 0.1, the distribution is regulated, showing the effectiveness of the constraint in balancing response lengths. In the related work section, several key areas are discussed. Firstly, the verifiability of large language models, LLMs, is addressed, where recent approaches focus on improving the reliability of LLM outputs through the use of citations and retrieval-augmented generation. However, these methods face challenges such as citation hallucination and the difficulty of verifying against retrieved documents. Secondly, Preference optimization is highlighted, where models are aligned to human preferences using techniques like reinforcement learning from human feedback, RLHF, and direct preference optimization, DPO. This is particularly relevant to our work, which uses DPO and quote tuning to steer the model toward generating quotes. Lastly, the memorization capabilities of LLMs are explored, where it is shown that these models can memorize significant portions of their pre-training data, which can be leveraged for better alignment and generalization, as seen in methods like KN and LMS. Table 6 presents the results of an ablation study on the length constraint within the quote tuning algorithm, specifically in the context of long-form question answering, LFQA. The study reveals that while quote tuning produces responses with lengths very close to those of the untuned model, 117.6 versus 115.9 on NQ, 179.6 versus 179.8 on ELI5, removing the length constraint leads to significantly shorter responses, 105.9 on NQ, 154.3 on ELI5. This suggests that the length constraint effectively regulates the output length and contributes to slightly better quoting and fluency, as indicated by the QUIP score and other metrics. The findings underscore the importance of the length constraint in maintaining the balance between response length and quality in the quote tuning framework. The authors discuss the potential of quoting as an interface for leveraging parametric knowledge in large language models, LLMs. They highlight the proposal by Weller et al., 2024, to quantify quoting using efficient membership inference tools like Data Portrait. This framework allows LLMs to generate quotes from high-quality data sources, enhancing their ability to utilize parametric knowledge at inference time. The finding on quote tuning suggests that carefully tuned LLMs can significantly improve their quoting capabilities compared to untuned models. This indicates a substantial underutilized potential in LLMs for generating more verifiable outputs through quoting. The authors hope these findings will inspire further research into employing the quoting interface and developing methods that are both attributable and verifiable. In this study, the authors introduce quote tuning, an algorithm designed to enhance the quoting capabilities of large language models, LLMs. The experimental results show that quote tuning significantly improves quoting in long-form generation tasks, generalizes well to out-of-domain data, and enhances model truthfulness. However, the work has several limitations. Firstly, it focuses on maximizing the amount of quoting as measured by the QUIP score, without distinguishing between many short quotes and a few long ones. Secondly, the experiments are limited to certain settings and do not explore other diverse task settings. Thirdly, the study only explores quoting as an interface for parametric knowledge, leaving potential synergies with non-parametric techniques uninvestigated. Future work should aim to address these limitations by maximizing both the rate and length of quoting, extending the experiments to diverse task settings, and exploring the synergy with non-parametric techniques. Additionally, the security implications of quote tuning, such as its potential to solicit sensitive data, need to be investigated. Finally, future research could focus on creating reliable, easily verifiable citations by attributing the source of citations with symbolic methods. Thank you for watching.